Hello everyone. Welcome to yet another interesting session on collections in Java. Today we are going to dive deeper into the set interface in Java collection and its hands-on implementation. But before we begin, make sure to follow our YouTube channel and hit that bell icon to never miss an update from Intellipaat. First of all, let's discover the agenda for today's session. We will begin this session by understanding details about set interface in Java. Once done with that, we'll discover both theoretical and implementation details of hashset class. Next, we'll look into the intricacies of the linked hashset class. And finally, we'll learn more about sorted set interface and its child class treeset. I hope I have made myself clear with the agenda.
So guys, without wasting any time, let's get started with our first topic, set interface in Java. The set interface is part of java.util package and implements the collection interface. It is, as the name implies, the programming interpretation of a mathematical set. This particular interface contains the methods inherited from the collection interface and adds a feature that restricts the insertion of duplicate elements by making use of hash table or hash map data structure. As of now, you guys must be aware that no interface can be instantiated directly. In order to inherit its properties, we will need a concrete class for declaration. What I mean by concrete class here is that class that is part of Java collection hierarchy and which extends the set interface. And most often, hashset, link hashset act as those concrete classes. We have one more class named as treeset which expands the sorted set and navigable set interface in collection framework hierarchy. In this particular session, we'll be more focusing on hashset, linked hashset and treeset. First of all, we shall explore the theoretical and implementation details of hashset. So guys, what comes to your mind when you think about word hashset? You must be visualizing it as a blend of hash table and set interface in mathematics, right? Well, yes, that is true. The hashset class is completely backed by hash table, which is actually a hash map instance in Java programming. This class provides constant time performance for fundamental operations such as add, delete, contains and size, providing the hash function appropriately distributes the elements throughout the bucket. The major thing to remember here is that the order of set iteration is not guaranteed. What I mean by this is that the hash class does not provide the constant order of elements over time. Now let's talk about iteration speed in set object. If you are intending to maintain a constant time performance, you'll have to figure out the right capacity and load factor. In order to iterate over hashset, generally you need time proportional to the sum of hashset instances size plus the capacity of backing hashmap instance. I think this is difficult to understand if you are unaware about the term capacity and load factor. But don't worry, I'll tell you guys what these variables are all about. First, we shall understand the term capacity. The initial capacity is basically the number of buckets formed when a hash table is employed internally by the hashset class. If current size is equal to initiated size or capacity, the number of buckets will get automatically raised to allow dynamic storage of multiple elements. Next, we have a load factor. This parameter basically specifies how full the hashset can become before its capacity is automatically raised. When the number of entries in the hash table exceeds the product of load factor and current capacity, that is multiplication of load factor and current capacity, the hash table is rehashed. What I mean by rehashing is that the internal data structures are rebuilt to have about twice the number of buckets than previous state. This load factor can simply be calculated by taking the ratio of stored elements in the table by the set of initial size or capacity of hash set. Remember, for the constant time performance, you should make sure that the capacity is not too high and load factor too low. Let's look into one example to better understand this concept. Consider that we have initial capacity value of 16 and load factor of value 0.75. The rehashing process is said to begin at an index equal to the product of 16 and 0.75, which means it will be 12 in this particular case. I hope this simple computation is clear to all of you guys. Moving forward, we'll understand the effect of capacity and load factor on hashset's performance. The load factor and initial capacity are two major aspects that influence hashset performance. In terms of time and space complexity, a load factor of 0.75 delivers extremely effective performance. If we increase the load factor number above that, the memory overhead will be decreased since the internal rebuilding procedure will be minimized. But that will for sure affect the operations such as add and search. Let me explain what I mean by that. Consider this container given on screen. The size of this container is 10 and we have taken the load factor parameter as 0.9. So this means when number of elements in container will become 9, the hash table will perform rehashing and double its size. This operation will access more memory in memory space and thus the space complexity will increase. However, if I am only intending to insert 8 objects into the container, then there won't be any requirement for rehashing operation, right? And this will definitely remove memory overhead from the equation. Now, if we had taken the default load factor that is 0.7, then memory overhead must have come into play. We could have wasted 12 bucket sizes, which is not effective if you have memory utilization as your primary concern, right? In addition to that, in our case, if we try to insert 9th element, then for that particular insertion, the complexity will rise as well because the IDE will have to perform the internal rehashing operation. That is why it is recommended to pick starting capacity intelligently in order to reduce the rehashing operation. No rehash operation will ever occur if the starting capacity is larger than the maximum number of entries divided by the load factor. So guys, choose this initial capacity factor wisely if you want to attain efficiency with hash set. We also mentioned previously that hash map is utilized to implement the hash set class, and it must have put you in doubt because to enter a value in hash map, we need a key value pair. But in hash set, we only pass one value, right? But let me clear this for you guys. Internally, hashset class stores the values you provide as keys of the hash map, whereas it stores hash map values as a constant. Now, as we know, keys can never be similar, so this notion itself allows hashset to maintain unique objects. Having said that, I would like to clear one more important thing, that the values we are going to enter into the hash set are by no means supposed to be singular objects. You can even store collections like array list, linked list, or vector. Not only that, but the hash set will also make sure that collections you enter or the objects you enter are unique by state. Having said that, I would like to clear one more important thing, that the values we are going to enter into the hash set are by no means supposed to be singular objects. You can even store collections like array list, linked list, vector, etc. Not only that, but the hash set will also make sure that the collections you enter or the objects you enter are unique by state. Now let's learn how we can create the instance of hash set class. We have 4 different approaches to construct the hash set. Let's begin with the generic constructor. The generic constructor syntax goes like hash set object type object name equal to new hash set object type. This constructor is used to build an empty hash set object in which the default initial capacity is 16 and default load factor is 0.75. The next constructor takes the initial capacity as a parameter. The syntax for this one goes like hash set object type object name new hash set then object type and under brackets int initial capacity. Here the initial capacity will be custom as provided by you guys and the load factor will retain its default value which is 0.75. Next we have is a constructor with 2 arguments, initial capacity and load factor. The syntax for this goes like hash set object type object name equal to new hash set object type and then under bracket initial capacity and load factor. With this constructor, we provide custom size and load factor to the hash set object at time of its construction. The final construction is used to convert any other collection into the hash set object. The syntax for this final constructor is hash set object type object name equal to new hash set then again object type and inside bracket the collection C that you want to enter into hash set. Next, we'll have a look at different hash set built-in methods. The methods shown on your screen allow us to perform different operations on hash set object. By making use of few of these methods, we'll try to operate and manipulate the object of hash set class. In order to do that, let's visit the code editor. First of all, let's create a new program file. We will name this file as hash set implementation dot java. Now this will create a class for us. So now the next thing will be importing the java.util library. So let's do that. Import java.util.star. Next step as usual will be creating the main method. So let's do that. Public static void main string args. Previously, while covering theory, I mentioned that set interface accepts collection and also make sure that entered collections are unique. Let's test that statement by adding collections into our hash set. So for that purpose, first of all, to do that, first we'll have to create ArrayList instances. So let's create two ArrayList instances at first. So we'll name it as ArrayList integer a1 equals to new ArrayList integer. Let's copy this statement and paste it again. And now we will change the object name, that is a2. Now we will create the instance of hash set as well. So the syntax for that is hash set, as we will be inserting collection. So we'll name it as ArrayList, our wrapper class, and then the object name equal to new, again hash set, and the wrapper type array list. Now we'll insert few elements into both the ArrayList objects a1 and a2. Let's do that with help of add function. So we'll do that now. And one more thing guys, we'll make sure that the objects inserted into a1 and a2 will be similar so that we can test our theory, right? So first object will be 12, then 2 and 87. Now let's copy all these commands. Okay, so we have now stored the same elements that we stored inside object A1 into object A2. So now let's print these objects one time. And let's run our code. You can see that the ArrayList objects are similar here. So now let's insert both these ArrayLists into our hashset object. So to do that, we'll again use add function hs.add al1 and hs.add al2. Since we have created two similar array lists, the hash set should only accept one collection. To check that if it is true, let's print the size of our hash set so that we can know how many objects are stored inside the hash set. So let's do that using system.out.println and inside it hs.size. And let's run our code. Okay guys, so the mistake that we have made here is we have named our objects as A1 and A2 and we have used AL1 and AL2 here. So we'll have to remove L from both the syntaxes and we'll run it again. Yeah, here you can see that the size of our hash set is only 1. Let's print our hash set once again to verify that. And let's run our code. Now you can see that we have only stored one array list inside our hash set. That means the theory that we discovered previously was perfect and accurate. Now to perform multiple operations, let's create one more hash set object. Hash set. This time we'll use integer as wrapper class and we'll name this object as hs1 equal to new hash set and wrapper class integer. Now we will insert few integer elements into this hash set object. Here we have entered few duplicate entries to check whether our hash set only takes unique values or not. So for that purpose, let's print our hash set and see if it accepts only unique elements. Let's run our program. Okay, I hope this should be fine now. Yeah, here you can see that all the elements inside our hash set are unique. So let's move to the next operation, that is printing the hash codes of both hash set functions. So for that we have hash code function. So we'll make use of it. System dot out dot println the hash code of hash set hs1 is hs dot hash code. Now similarly we'll print the hash code of hs as well. Now let's run our program. Here you can see the two hash codes. One is 91, another one is 41472. This hash code value that you are observing here is the 4-bit value generated by hashing algorithm. This unique value actually enables you for quicker object access. I hope this is clear to all of you guys now. So let's move to the next operation, that is iterating the hash set object. For that, we'll be using iterator method inside collection hierarchy. So let's call the iterator class for that. The object type is integer and we'll name this object as itr equals to hs1 dot iterator. Now we'll use while loop for traversal and inside it we'll pass argument itr dot has next, and inside body we will print the objects of hash set. Let's run our code. We have used hs1 here, it should be itr. Okay, here you can see that all the elements are printed with traversal. Now let's move to the next operation on our list, that is the removal of hash set elements. So for that we have remove method and we'll have to specify the value that we want to remove. We'll remove 32, then hs1 dot remove 11, and from hs we will remove the only object present, that is a1. Now let's print both the hash set objects to check if removal has happened or not. First we'll print hs and then we'll print hs1. And now let's run our code. See guys, here the hs should be empty as we have deleted the only entry present inside it, and previously the hs1 had 5 elements and now it only has 3 elements because we removed 2 elements from it. I hope this operation is clear to all of you guys. On that note, let's visit the PowerPoint presentation for next topic. Now we will discuss the theoretical and implementation details of link hash set class. The link hash set, as its name suggests, is a blend of doubly linked list and hash set data structure. The hash set makes sure that the contents are unique, whereas the linked list maintains the order. You can consider the link hash set as an ordered version of hash set. When you want to remember the traversal order, this class is utilized. If you iterate through the hash set, you'll get the random order, whereas if you iterate through the link hash set, you'll get order as per the insertion you have made. Let's discover the methods that come with link hash set. We'll utilize a few of these methods to create and manipulate linked hash set object. But in order to do that, let's visit our code editor. Now let's create the program file for linked hash set implementation. We'll name this file as LHS implementation.java. So this will create a class for us. As usual, the next step will be importing java.util library. After that, we'll create the public static void main method, and inside it we'll pass argument. Now we'll create the instance of link hash set. To do that, we have command link hash set, then wrapper class. Here in this particular example, we'll be using string as an wrapper class. Then the name of instance that you are going to create, let's name it as LHS here, equal to new link hash set, and again we'll pass string as an wrapper class. Now that we have created the object of link has set, we will insert few elements into it. LHS dot add Intellipaat, then Java, then collections, tutorial, then let's add A, then we'll add X and small x. After these operation, let's print our LHS, that is link has set instance. And if we run our program, you can see that the duplicate elements have not been included into our linked has set object. Only the unique elements has been included. That is Intellipaat, Java, collections, tutorial, A, large X and small x. Now let's move to the next operation, that is iteration of link has set. To do that, we are going to use iterator method. So for that, we'll have to call iterator class. The object type will be string this time. Then the object name itr equals to LHS dot iterator. Now we'll print one statement, iteration order of link hash set, while itr dot has next system dot out dot println itr dot next and semicolon. This command will print elements one by one to the next line. Now let's run our code and see if it is working fine or not. Now here you can see that iteration order of linked list is Intellipaat Java collection tutorial AXX, which is exactly similar to the insertion order that we have followed to insert the element. So from this we can say that the link has set maintains the insertion order. Now moving ahead, let's perform the next operation on our linked has set object, that is converting the linked has set instance into the array. To do that, we'll create string array and we'll provide it size of 10. Now we will convert our linked has set object into array using toArray method. So the syntax to do that is LHS dot toArray and we'll pass ARR as an argument, which is nothing but the array that we have created. Now the next step that will follow is printing the elements from this array. For that we are going to use for loop, but before that let's add one statement about that. The contents of array are, and then semicolon, and then we'll iterate using for loop. Int I equal to 0 to I reaching till array length I plus plus. And with this for, we will print. Now let's run our code and see if it is working fine or not. Okay guys, we'll have to convert this into string array. Initially it was just a string, so that's why it threw an error. So let's run our code again. See, the contents of array are Intellipaat, Java collections, tutorial, AXX, null. Basically, these null values are the empty spaces that we have inside our array. So I hope this part is clear to all of you guys. Now let's move to the next operation, that is checking if specified value is part of linked has set or not. To do that, we have function named as contains. So we'll use it inside system.out.println method and we'll print check if x is part of linked hash set, and we'll pass call to the function LHS.contains and x will be its argument. Also let's add let's add one more operation to this list, that is removal of elements from link hash set. And to do that, we have function named as remove LHS.remove small x, large X, then LHS dot remove A. These objects should be string type, and then LHS dot remove Java. Now let's print the state of our array after removal of element LHS. If we run the program, you can see the elements have been removed, that is 3 elements X, A and Java. Also the contains function, let's check the command for that as well. Here you can see that check if X is part of linked hash set and it is returning true. That means X is part of our linked hash set. I hope all these operations are clear to all of you guys. Let's move to the presentation slides to understand the next part of our session. The next topic we have is sorted set interface in Java collection framework. The sorted set interface extends the set and collection interface. This interface is implemented to add a feature that can store all the elements of a set in a sorted manner. But since the set doesn't maintain an insertion order, it is not possible to sort its element. But not to worry, Java collection framework has a solution to that. The class named navigable set extends the sorted set interface and provides the implementation to navigate through the set. The navigable set is implemented by a tree set class. Moving forward, we'll discover its intricate details. Tree set is one of the most important implementation of the set interface in Java that implements the tree data structure for storage. In tree set, the ordering of objects is maintained by a set using their natural ordering, whether or not an explicit comparator is provided. It can also be ordered by a comparator provided at a set creation time, depending on the constructor that you are going to use. Let's discover the working mechanism of tree set interface. Tree set is essentially a self-balancing binary search tree, similar to red-black tree that you have studied in data structure. As a result, operations such as add, delete, and search require big O of log n time. The reason for this is that in a self-balancing tree, the height of tree is always big O of log n for all operations. As a result, this is regarded as one of the most efficient data structure for storing massive sorted data and performing operations on it. Printing n elements in sorted order, on the other hand, takes big O of n time with a tree set instance. A tree set's implementation is not synchronized. This means if many threads visit a tree set concurrently and at least one of them updates it, the set must be externally synchronized. Typically, this is performed by synchronizing some object that naturally encapsulate the set. If no such object exists, use the collection.synchronizedSortedSet method to wrap the set. This is best done at the time of set construction to avoid unintentional unsynchronized access to the set. It is possible to accomplish this with command sortedSet, then object type, object name equal to collections.synchronizedSortedSet, and then again the object name. Next, we will discover ways to construct a tree set class. Tree set constructor. The generic tree set constructor is used to build an empty tree set object in which elements will get stored in default natural sorting order. The syntax for this constructor is tree set, then object type, object name equal to new tree set, then again inside wrapper object type. Next, tree set constructor is used to build an empty tree set object in which elements will need an external specification of the sorting order. The syntax for this constructor is tree set, object type, then object name equal to new tree set, object type, and then the comparator that you want for ordering. The third constructor on our list allows you to build a tree set object containing all the elements from the provided collection in which elements will get stored in default natural sorting order. In short, this constructor is used when you want to convert the collection object to a tree set object. Syntax for this constructor is tree set, then object type, object name equal to new tree set, then inside wrapper class, object type, and the collection that you want to insert into tree set. The last constructor allows you to build a tree set instance containing all the objects from the given sorted set in which elements will get stored in default natural sorting order. In short, this constructor is used to convert the sorted set object to the tree set object. The syntax for this constructor is treeset object type object is equal to new treeset, and inside it will pass sorted set as and parameter. On that note, let's look at treeset methods. We'll implement a few of these treeset methods in order to accomplish manipulation operations on treeset instance. Let us visit the code editor to achieve that. First of all, let's create the Java programming file. We'll name this file as treeset implementation.java. This will automatically create the class for us, and again we'll have to import java.util library. Now we'll create the main method as well, and we'll pass string args as an argument. Now we'll create the instance of treeset class. For that we have command treeset, the wrapper class. We'll use integer as an wrapper class for this particular example. The name of treeset object equal to new treeset, and again the same wrapper class. Now we'll create ArrayList object as well. Al equal to new ArrayList. Now we'll add values into the ArrayList, and then we'll store this ArrayList into our tree set. So for that, let's add few values into our ArrayList. Add 5, 10, 20, 21, 5 again, 10 again, 32 and 40. Now we'll print our ArrayList. Now we will use addAll method to insert all the entries in ArrayList to our tree set. So to do that, we'll use ts.addAll method, and inside it we'll pass ArrayList collection as an argument. After that, we'll print our tree set as well. Now let's run this program. Here guys, this is the printing of ArrayList object, and this is the printing of tree set object. Here you can see that duplicate elements have been removed from our tree set object. That means tree set only contains unique objects. Now the next function that we are going to do is adding few elements into our tree set. For that, we'll use add method. 22 ts.add 11 ts.add 1. Now let's print the size of our tset object. ts.size. Now we'll check the first and last element of our tree set using ts.first and ts.last method. For that, we'll print statement using system.out.println command, and the statement that we are going to print is first element of tree set is ts.first, and similarly last element of tree set is ts.last. Now let's run our code and see if both these functions are working fine or not. Here you can see the first element of tree set is 1 and the last element of tree set is 40. What this implies is tree set, as we mentioned in theory part, implements the sorted set interface, which actually sorts the entries that we are making into our tree set. That means if we print our tree set, we should get the proper ordering of our elements. Let's try to do that here. See, here you can see that all the elements are ordered according to their numerical value, right? Not according to insertion or not randomly, right? I hope this operation is clear to all of you guys. Now let's move to the next function that we have on our list, that is removing the first and last element from our tree set. To do that, we have two methods. First one is ts.pollFirst and then ts.pollLast. Now let's print our tree set object to check whether both the first and last elements has been removed or not. Here you can observe that 1 and 40 has been removed from our tree set object because of the method poll first and poll last. Now let's move to the removal operation. TS dot remove the specified value, that is 4, and TS dot remove 32. Now 4 is not part of our tree set object, but let's check what output it returns. Now we'll also print the state of our tree set object, and after compilation we can see that only one element has been removed from our tree set, that is 32, right? Because 4 was never part of our tree set instance. Now let's perform one more operation, that is clear operation, which will remove all the elements from our tree set instance. So the command for that is ts dot clear, and will print the state of our tree set instance again. Here you can see that all the elements from our tree set has been removed. I hope this hands-on programming implementation of tree set and manipulation operations that we covered in this program are clear to all of you guys. Thank you so much for being here till the end of this session. I wish you all the very best in your endeavors of mastering Java programming. If you want to come across more sessions like these, then hit that subscribe button and also press a bell icon to get multiple digital technology updates from Intellipaat.
Just a quick info, guys. Intellipaat provides Java certification online training, mentored by industry experts. The course link of which is given in the description below.